All right, we are here to talk about code signing best practices pre and post HSM in the enterprise. So basically, back in June 2023, the industry standards around private key storage changed. And basically, certificate authorities or anybody that are issuing code signing certificates are requiring that private keys code signing certificates be stored on a hardware certified device, certified as, I guess, FIPS 140 level 2. I got that correct. Common Criteria EAL 4 plus or equivalent. So effectively, in a pre-HSM world, you would purchase a code signing certificate from a certificate authority. GoDaddy sold them. You could get them from DigiCert, Sectigo, different places. And typically you would just purchase a code signing certificate. You would go through their verification process and they would issue you certificate files, typically a .cer, .pem, and a variety of other files. And you would take those and you would complete the certificate signing request. And you would produce typically a PFX file. And that basically is the certificate that also contains the private key, because certificates use public private key encryption to do cryptography. And basically that private key would be self-contained in that file. And typically then you could use that for code signing. We're going to talk about today, what is best practice? What should that be? And what should that look like in the enterprise? And we're going to talk about it from the perspective of maybe a single engineering team all the way to many, many engineering teams and different product lines where there's a lot more people involved. And we're going to go all the way from basically who should oversee certificate management, who should use certificates. We're going to talk about how to manage those, how to issue those. We're going to talk about how to use those and what is best practice pre-HSM. And we're going to talk about best practice post-HSM. Okay. So to kind of reaffirm why we're talking about this in 2024, because of this industry standard change, if you have a pre-existing code signing certificate that you had purchased and was issued to you prior to June 1st, 2023, and as long as that certificate has not expired yet, you can continue to sign your code and reap the benefits of code signing. Okay. Once that certificate expires, then you have to purchase a new one, and you are going to basically be required to purchase a certificate from a certificate authority. And now you're going to have to do it in this post-HSM world, which at the end of the day basically means they're going to do the normal stuff and issue you a code signing certificate, but they're also going to issue you typically a physical USB e-token device. It's basically a special USB device that acts as a smart card. And the way I think about it is it's effectively multi-factor authentication for code signing. And basically what they're doing at the end of the day is they're basically saying, we're not going to actually make the private key to these certificates easily accessible. We're going to protect that private key. And the way they're doing that is through these encrypted USB smart card or e-token devices. And there may be other ways to do it, but the USB device is basically the common one. And the major issue with that's happening in the industry, and we're actually dealing with this at my primary job right now, is it creates infrastructure challenges, which we're going to talk about. So I want to first step back, and we're just going to very quickly, I'm not going to cover this at depth because I'm assuming that if you're listening to me blabber on about this today, I'm going to assume that you are already doing code signing and you're being impacted by the new HSM requirements. And maybe you're trying to navigate this ocean and all the waves and like, what do we do? Maybe your certificate's already expired. Maybe you've purchased a new one. Whatever the case may be, that's all fine. So briefly, we're going to talk about what is code signing and why should you actually do it. And effectively, it provides confirmation that your distributed files were authored by you. It provides confirmation that your files have not been tampered with, and it effectively provides a level of trust to your clientele. It's more trusted by antivirus software. Your files are more trusted by things like Microsoft Smart Screen. And basically, you can also use code signing and that digital signature in your output, your artifacts, your DLLs and executables to build your own verification and validation features. I can give one example from a product I know of where they were basically using the code signing signature of their files to do verification that for their automatic update process of a program, that the new program that it would download from a server is in fact authored by them. And so you can use it to do things like that. So that's why you should use code signing. Now, if you're not concerned about those things, you don't need to do code signing, but it's generally recommended that you do code signing for that level of trust. You want to pass those different things like Microsoft Smart Screen. You want antivirus programs not to flag and quarantine your software and so on and so forth. And so generally is best practice, but it does cost money. It does require to have good practices in place at your organization or in your team. And we're going to talk about not just best practices, but we're also going to talk about bad practices, what you should not do. Because what I see and what I hear throughout my career is I've seen and heard some really raunchy things that people are doing with their code signing certificates that would basically cause your code signing certificates to potentially be vulnerable or they could be compromised. And effectively, I think what triggered a lot of this is there actually was a couple things that happened. I think this was in 2022, and I don't know the whole entire story, but effectively, I think there was a situation where in 2022, NVIDIA had a data breach and effectively their code signing certificates were compromised. And I think there was a similar thing that happened with ASUS. And so I think a lot of these data breaches and compromisation of these certificates have led to more scrutiny and kind of a, basically if someone got a hold of your certificate and they had your private key, then they could use that to sign files that are theirs, okay? And then basically they could make it look like, hey, I distributed an NVIDIA file, but it's actually mine, and maybe it contains malware, and it's signed with your certificate, and okay, right? That's a way to compromise the security of your application and ultimately your customers. So we're going to break this down into a couple different categories. We're going to first talk about in the enterprise, and even if you're a small company with just one engineering team, like even a couple guys, this applies. So we're going to break it down into single team versus multiple team. I'll get into that later, but we're going to start with who should actually oversee certificate management in your organization. And even if you're actually just an individual, this applies to you as well. Maybe you're just a individual developer doing an open source project, or maybe you're trying to build your own product or whatever. Everything I'm talking about applies, I think, equally across the board. Okay, so who should oversee certificate management? So in my opinion, and you can go read out there, and I would strongly argue this is best practice, okay? Because most large software organizations, Microsoft, other places, are probably doing something similar. Generally speaking, the purchasing, initial storage, issuing, installation, and revocation of your code signing certificate should be handled by a central authority. And when I say central authority, that should either be your IT group at your company, who also manages your software subscriptions, your SSL certificates, your environments, your IT infrastructure, or it should be a similar group within your engineering division. Okay, it doesn't have to be strictly owned by corporate IT, who doesn't necessarily deal with software engineering things. Okay, but there should be a group responsible for the certificate management. Okay. It's generally going to be the IT group because they're also the ones purchasing your other certificates and managing domains and all that kind of stuff. Okay. Who should use certificates? Because the IT group is not necessarily going to use code signing certificates. They might, maybe they develop PowerShell scripts. Those can be signed, if I recall. Maybe they're developing small programs or whatever, and maybe they have a need for code signing. So they might actually need to use them as well. But primarily, it's going to be your software engineering groups, okay? The people actually writing code, building components, producing software artifacts, the software artifacts actually being executable files, dynamic link libraries, and other binary type artifacts that can be code signed, and so on and so forth. Okay, so pre-HSM world, what does that actually look like? Okay, so you should purchase the certificate, and in a pre-HSM world, you'd buy it from the certificate authority. They would do all that work. They do verification of your information. So if you're actually an organization, they'll verify your organization details, typically your address, your phone number. They'll make sure you're legit, effectively, okay? And that's part of the trust factor of actually doing code signing. As you can say, there's these well-known certificate authorities. I think Microsoft is actually one, and there's all these others, DigiCert, Sectigo, and basically there's a level of trust in saying this well-trusted entity in the industry has vouched for us and validated and verified our information and what we're saying to be true, and has issued us this certificate with that information in there. And that's where you get a level of trust. Okay. So pre-HSM world, they would issue you those certificate files. You could download them from their portal in a zip archive. You would basically, and to kind of back up, you basically would have started this process with a certificate request with your information in there. And you can do that through IIS actually. And there's actually other command line tools, I think like OpenSSL and maybe some other things you can do this with. But you would then provide that request, it's called a CSR, to the certificate authority, and then they would basically take that information and go through that process we just explained. Okay, you get those back, you download them, you have the files, and then, again, typically through IIS is what I've actually used, just because it's really simple. You will complete that CSR, and the completion of that CSR will actually produce the final certificate. And one key factor here is that the machine, the physical machine, the server or workstation that you created that CSR on also has to be the same server or workstation that you complete the CSR. That's part of the whole security chain, okay? So if you sent a CSR and you try to complete it on a different machine, you're not going to successfully produce the private key and the completed certificate, okay? So that's part of that process. Okay, for us, typically, if you're just like a small shop or an individual, that might be your build machine, or maybe it's your workstation if you're just an individual, or maybe it's a release server. We'll talk about that in a little bit, but you will complete that request. And pre-HSM world, then the question becomes, where do you securely store the certificate? What is actually the best practice? So I have effectively a PFX file, and in the Windows operating system, it'll actually have the PFX file icon, and if you've done it correctly, you'll actually have a little key icon on top of it as well. That's showing that that PFX file contains the private key, meaning that that self-contained file has everything you need to do code signing. Okay, now when you also produce that PFX, you also have the option to password protect that PFX, okay, which you should do initially. Okay, you don't have to, but it depends on how tightly controlled your process for completing the CSR is and who has hands on this. Typically, this is something a person should do. Okay, so I've downloaded the files. I have completed the CSR. I have a PFX file with the private key. Password protected or not, what's the best practice? Okay, well, typically, you should be installing that code signing certificate. Probably, if you don't have any other mechanism for it, you should have a machine that you've designated for requesting and completing CSRs, and that's where you do all your certificates, a very tightly controlled and locked down environment that maybe only your IT group has access to, or whatever group we talked about that oversees certificate management has access to, okay? And that certificate should be at least installed inside the Windows Certificate Manager. And on that machine only, should it probably be marked as exportable, because then there's the rest of the process of now we're going to have to issue this certificate to other places. Now, that's the most basic way to do that. There might be other software solutions. One of them is actually like Azure Key Vault, where you can actually import your certificate into Azure Key Vault, and it will securely store your certificate in Azure, in the cloud, in the Key Vault, and you can actually store your password if you password protected that certificate. You can also store that as a secret in Azure Key Vault as well. So you can have somebody log into the Key Vault, and you can obtain the password when you need it. You can also download the certificate, but it's all stored securely in the Azure Key Vault. That's actually my favorite approach. That's actually currently what we do versus having it installed on a actual machine. And Azure Key Vault actually does have the ability to, I believe, generate CSRs and complete CSRs as well. So I'm just basically describing probably pre-HSM world. The two most basic options that are out there is probably completing that and having a machine, Windows Certificate Manager, where you put that, and then Azure Key Vault is a really great option that's been around for a while. There might be other third-party software products and tools that do key storage and certificate management. Those are possibly viable options. But in a pre-HSM world where you would have the private key and you could store all of that securely, including the password. Those would typically be probably best practice pre-HSM world. What you shouldn't be doing is storing that PFX on a network share, just in the NTFS file system where somebody could grab that. You should not be storing your password in a text file. I wouldn't even recommend storing that password. I mean, you could store it in like a password manager, but you basically should not have that PFX file sitting on the file system. That should not be doing that. So that would be the opposite of best practice, okay? The problem with that is people, if they compromise your system, they're able to get their hands on that certificate, a copy of it, then they can use that certificate for code signing. Okay, so the idea of storing it in the cert manager or in Azure Key Vault, it's in a place where it's not readily accessible by humans to extract it and use it. And even if you have the cert in the Key Vault, you have to download that. And if it's a password protected cert, which I think Azure Key Vault requires, they would also have to, like if they were, let's say they, because obviously you'd have to get into Azure Key Vault to download the cert, but let's say they somehow got a copy of your cert, but they didn't have the password because your password is in Azure. So maybe somebody downloaded the cert and then maybe they put it in a file or folder somewhere and someone was able to access that, but they don't have the password and that password is also in Key Vault. So, you know, there's different ways that can be compromised, but you basically want to minimize where that PFX file actually is, pre-HSM world. Okay. But effectively, the certificate authority is going to give you, in a post-HSM world, this USB e-token device, and that device is going to actually contain the certificate files and everything you need, but that USB device has to physically be connected to the machine to access that information. And also, typically, they're going to combine that USB e-token device with their proprietary software. So like Sectigo has one called SafeNet Client Authenticator. And so you have to physically, they give you a USB key, you have to plug that in to your machine, and you have to also have the client, SafeNet client installed. And through the combination of those two things, then you can do code signing as you always did, but you don't actually have the raw certificate files anymore. Okay, so that's post-HSM world. So what's changed is pre-HSM, you're going to have the raw certificate files. You're going to have the ability to create a raw PFX file with a password, so you have the private key in there. And you're going to, in a post-HSM world, now you have this USB key combined with proprietary client software. Okay, so that's the change. And to dumb it down, basically the change is, right, they are protecting the private key. Okay, so that's pre-HSM, post-HSM. So best practice doesn't actually change too much in a post-HSM world. However, there's an infrastructure challenge introduced now because it's no longer just a file. Now it's a physical device, okay? Which means that it has to be plugged into a physical machine. And to do code signing in a post-HSM world, the code signing has to happen on that machine that has the USB device and their proprietary software installed. Okay, there's no PFX file. There's no certificate in the Windows Certificate Manager that I'm aware of anymore. So now there are some options to export certificates from these devices, but they're not going to be exported with the private key, I believe. It depends on the software vendor. And as I understand it, there's potentially different implementations of how vendors are actually doing this. Okay. So that's kind of the management of certificates. You know, who should oversee it, who should purchase them, who should manage them, who should store them, and that we don't really have to talk about revocation of certificates too much, because if your certificate is compromised, your IT group or central authority that's managing them should basically go through the process to revoke that certificate. You resolve your vulnerability that led to the compromise, and then you basically get a new certificate. Now we need to go into how do we now issue certificates, and we'll talk about pre-HSM and then post-HSM. Now that there's a infrastructure challenge with the physical USB devices, what does issuing certificates to the groups that actually need to use them look like? And we're going to talk about a couple other things, like what does that typically look like pre-HSM today with multiple development groups involved, because this is where we get into, there's a lot of really bad practice I see out there. And so Basically at the end of the day, the engineering groups are the people that need to use this stuff. So we don't want to turn a mountain into a molehill and basically make it impossible for engineering groups to do their job. We don't want to apply a level of criticality and scrutiny and security to this in such a way that basically they can't function. So there's a balance that has to be achieved to say, okay, we have this central authority that handles the purchasing and management and issuing of the certificate within the company. I will also add very quickly to answer a common question that often comes up is how many certificates should a organization have for code signing? And the answer is typically one. You have one code certificate. It depends if you have different technical requirements. If one group needs an OV signing certificate versus EV, we're not going to get into that. But generally speaking, one organization with your corporation name should have one code signing certificate unless there's another separate technical reason or legal reason why there needs to be separate certificates. Maybe the certificate information itself needs to display a different physical location, different address, different authority name, or entity name rather. There's different reasons for that. But generally speaking, your one organization should have one code signing certificate. Okay. So we've established that. So how now do we take these certificates, pre-HSM and post-HSM, and now in a secure way that prevents copies in a pre-HSM world from existing and in a post-HSM world addresses the infrastructure challenges? How do we make our code signing certificate available to the people that actually need to use them? Okay. So we're going to talk pre-HSM first, obviously, because this is where it gets really interesting. In a lot of smaller software companies or organizations that have not adopted any kind of best practices, it is actually often the case that different engineering teams were able to purchase their own code signing certificates. So they have their own, and they've had their own process for overseeing certificate management as well as using their certificate, and everything has been under their control. Okay. That is one plausible scenario that I have heard about and also seen in practice. Other places that might actually have a central authority, but we've seen things like the PFX files out on network shares and file folders, and different developers have access to it. Okay. So your central authority, and this applies in both pre-HSM and post-HSM world, at a minimum, the certificate needs to be made available to the actual physical environments or virtual environments where code signing actually needs to happen. Now that's going to depend on a lot of different factors. Okay. Are you manually doing code signing? Meaning I'm building my software, I've built that out, maybe I produce the files locally on my workstation, and I manually using the command prompt called Microsoft Sign Tool, and I manually sign the files that need signed. And maybe that's a person on your development team. Maybe that's anybody on your development team can do that. Okay. But somebody actually has to do that, and it's a manual process. So effectively, they need that certificate. Pre-HSM world, they need the PFX with the private key. And maybe in a pre-HSM world, bad practice, maybe they have that in the file system. Maybe they have it in the cert manager on their workstation or multiple workstations. Okay, that's maybe bad practice. Well, the best practice would basically be that the central authority should really push that certificate out to the Windows Certificate Manager through a deployment mechanism. So there's no hands-on with the physical file. And when that gets deployed and imported into the certificate manager on the systems that need it, it should be marked as non-exportable. Okay, so it has the private key, but it's not exportable. So on that system that it was deployed to, somebody cannot go into the certificate manager, right-click that certificate, and export it. If they were to export it, it would not have the private key, right? It's the private key piece that's non-exportable. So they could get the cert out, but they don't have the private key. Therefore, it's not usable. Okay, that's best practice. What also is best practice is typically the individual developers on a dev team should actually not be doing code signing on their local workstations. There shouldn't actually even be multiple workstations that you do this on. Generally speaking, a development team should have a code signing system. Now, whether it's one or multiple depends on a couple different things. Do you have a build system like TeamCity, TFS, or something like that? And then you need to do code signing on the environments where your build agents are installed and actually build your code and deploy the artifacts. It is perfectly best practice to install the cert pre-HSM on each build agent environment that needs it. Okay. It is also best practice, in my opinion, you would take a build agent or whatever build agents are necessary for your build process and separate out one or however many build agents you need into a separate release environment. So that way your build system can be configured in such a way that for all your typical builds, the dev team actually uses a self-signed certificate for development and test for all their daily builds all the time. But when it comes time to actually produce the final release, you run your build on your release build agent or agents that are on those environments that can actually do code signing. So that way your code signing certificate is on separate environments used for that purpose only. And those environments really only need to even be up and running when you're actually ready to do an actual release. So if you're going to do a hotfix patch or a minor release or a major release, right? Because we do, as an example, you might do hundreds of builds a day or week normally for development tests, but you don't actually need the real code signing certificate during that aspect of the SDLC. But when you actually need to ship stuff to customers and version it, then you need the real certificate. And that would be, in my opinion, the best practice is you have separate build agents parsed off on release environments for that purpose. Okay. And pre-HSM, that certificate is only existing in the Windows Certificate Manager as non-exportable. And those build systems generally will probably be under a virtual private network, not publicly accessible to the internet, and off until such a time comes where you actually need to run the release build. Okay, so it's tightly controlled. But the dev group, the benefit of that approach is the dev group has full control over those build agent environments. So all their build tooling, their build process, their build steps, their build configurations, everything is autonomous to what that team needs. Okay, so there's no impact to the organization. So the central authority can issue the cert one time when they get it to those environments, pre-HSM, and all that's good to go. Okay, but the cert should not be on developers' workstations. You should not have the physical file. You should not be signing files with the certificate password. That's another thing we should talk about, is that pre-HSM world. Now, even in a build agent environment, you should be using either the certificate thumbprint, which is a public value, or nothing at all, because the sign tool, if there's only one valid code signing certificate installed on the agent environment, will know to automatically select the code signing certificate properly. And so you actually don't need a thumbprint or password at all. So when you call signtool.exe, you should not be providing a password, okay? Because it's a non-exportable certificate from the cert manager, not using a physical file. Okay, so that's best practice pre-HSM. And typically those environments, your developers should not have access to them. You should have maybe like a release engineer, maybe an engineering manager that has access to those environments. Okay, so this is maybe in context of like single team. Now in context of multiple teams, it's just a matter pre-HSM of scaling that architecture out, because the certificate can be deployed to each team's physical environments where they would do code signing. Every team can just maintain their autonomy. So pretty straightforward. Now post-HSM world, the issue is the infrastructure changes that happen. Now, if all development teams are on the same physical infrastructure, basically the challenge now is, instead of digital files, now we have to deal with physical USB keys. So the question is, who actually gets USB keys? Well, it would be each engineering team would need to have a USB key, right? And now it can't be, again, we talked about bad practice of individual developers signing on their workstation. How you shouldn't be doing that. So if the baseline architecture is that each engineering team has a code signing environment and it's a physical environment that they can have access to, then it's a matter of just replacing the digital certificate file now with plugging in the USB key and installing the client software from the vendor like Sectigo, SafeNet, Client Authenticator, and everybody's good to go. And there's no impact on any dev team. They can continue signing code as they are today, calling sign tool. They might have to update the sign tool commands, but otherwise their build processes, their build steps, their build configurations are all unique and specific to their product and their team and their code don't change. Where it gets very complicated is infrastructure, because often what happens in larger organizations is because of the different needs of different engineering groups and the different product lines, there's often different physical infrastructure, especially over time as companies also do things like acquisitions. And so they've acquired different engineering groups and different products over time. And so maybe team A, B, and C are using infrastructure in the cloud through something like AWS or Azure, and they don't have access to the physical machines, where maybe there's teams E, F, G that are on site at maybe the corporate location who are on that physical network, and the machines that they do code signing on are all on that network. Okay. And so now we have an infrastructure challenge. And so the goal of, like we talked about earlier, of actually building out this release infrastructure, a release server where people install build agents for the dev team, is really for the purpose of solving these infrastructure challenges in a way where one team's needs aren't dwarfing or persuading the needs of other teams. So that way the teams can remain autonomous, and the only shared infrastructure is just the physical networking and the physical server environment that's provided. And so by doing it that way, what you're avoiding is saying team A needs to VPN and network their infrastructure to team G, because maybe that's the infrastructure that's chosen to do code signing now because they're on-prem. And maybe other teams need to network, and basically can create this network infrastructure disaster effectively. Okay. And now each team is dependent on maybe one team's infrastructure for code signing. And so anything that team does in the future, all teams are now dependent on that. Okay, so if they decide to change how they do code signing, and they just decide on their own how that should be, and then that now is dictated to all the other teams, there's some problems with that, because they're first and foremost going to do things that work for their team, and they're going to set their own needs above the needs of all the other teams, generally speaking. Okay, so that's the point of really having the IT group control the release server and code signing environment itself, but making build agent environments available to the teams. So you're basically putting that control in the IT group in a way that's agnostic to the development teams, in a way that still works for all the development teams. And now everybody's on equal footing. And each team, I can adapt my build processes for my product and my build steps and my configurations, and you can adapt yours however you need to. And there's no impact, but we all have the same access to be able to code sign. Because the thing that we all have in common is we just simply need that physical access to the USB key, the decryption of the token through the proprietary software. But what we need to not have in common necessarily is our specific build processes and build steps that are unique to our products. And we need the ability, each team needs the ability to adapt as they're developing their own product, because every team is going to have its own schedule, its own sprints, its own product vision, its own roadmap. Everything is going to be completely different. So really the point of it is to avoid this cross-contamination of your dev teams in a way where you're creating complex dependencies within your dev teams, and not just product dependencies, but also infrastructure dependencies. Okay, so you just want it as simple as possible. So that would be, in my mind, really best practice, is you want that environment to be centrally controlled, probably by your IT group. And you really want to utilize the build agent infrastructure that a lot of these build systems provide, and they all have it, build TeamCity, TFS, Azure DevOps, all have the ability to install build agents on an on-prem environment, and whether that's a virtual machine or a physical service, doesn't matter. They basically all have that capability to do so, and then each team has full control of those environments. Okay. And you can imagine the types of problems that can exist in such an ecosystem where you have one dev group kind of mandating, hey, you do it our way, but we're doing it this way because it's our product and that's how we've designed it to be. And then everybody is kind of at that mercy, let's say. But now, because of that dependency existing, now one product is completely dependent on that other, and that's not how it should be. If you're building products independently, different product lines, they need to be able to have their own release cycle, their own product roadmap, everything, and you need to maintain that autonomy for a variety of reasons. I don't think I actually need to really get into that because it affects not just the engineering side, but it also affects product management and ultimately customers. Okay. So I think the thing with that is, a lot of what I've seen is, if you are doing things properly, or your IT group is that central authority, and you have the right release infrastructure for code signing, basically a code signing environment, and you're actually using build agents properly, or you have something similar to that, and teams can be autonomous, you're probably going to be in good shape. If you're not doing those things and you're having to figure out how to make all this work, then you're going to end up in a scenario where some teams have a solution, other teams do not, or a lot of teams end up having to do a lot of heavy lifting to change their physical infrastructure or virtual infrastructure, and possibly also change their build steps, their build configurations, and how they actually build their products. And the easier of the two is to build out the proper physical infrastructure, right? What's harder is to make everybody do a heavy lift that caters to one way of doing it that's not really scalable for the organization holistically now and in the future, right? Because it gets a lot more complicated the more teams you start adding into it and the more your infrastructure grows over time, right? You can't have one team's infrastructure dictating the infrastructure for all teams. It really needs to be more the IT group infrastructure is provided, and teams have the ability to consume that and utilize that to their advantage while maintaining their autonomy, right? So I can put some diagrams up and we can kind of look at those in terms of like what might best practice as I described it look like versus maybe more poor practice, in my opinion. And I think we can see the differences, between the two. Okay, so let's actually look at some architectural diagrams of what this infrastructure should actually look like. So in the most basic example, we have basically everything on the same physical infrastructure. Okay, so they're all on network A, and maybe multiple teams each have their own build server, one being Team City, TFS, whatever that might be. And in the most easiest solution, you simply just purchase a USB, HSM, or e-token device from the code signing authority for each system. That is the most trivial scenario, and everybody basically remains as they are. They don't have to change their build process. They don't have to change their build steps or build configurations. They don't have to change any of their physical infrastructure. You simply replace the concept of pre-HSM, a PFX, the private key, and the Windows Certificate Manager now with the USB HSM and the client software installed on the build environment. And that is the most trivial of cases. Now, if you are not in a situation where you have a build server environment, that's the model that you would need to gravitate and migrate towards. So let's say you are assigning manually locally on your workstation, or you have a server, but you're manually signing on that environment. And honestly, manual signing isn't so much an issue. You just replace the concept of build server with manual signing. And instead of calling it a build server, it's your code signing server. But the idea is that you are having an environment for code signing, one environment that's locked down, only accessible by the people actually needing to do code signing, and it's tightly controlled. Okay, and that environment is accessible and available to the engineering groups who need to do this and use this. And that is the most simple case. So for most people, they fall probably under this scenario where everything's on our same physical network. We simply just replace the digital certificates now with the USB HSM and we're good to go. Okay. Maybe a minor update to the sign tool command in their build process based on the new type of certificate that they've purchased, but pretty trivial. So the scenarios get a little bit more complex though, and we go to scenarios where maybe you do have different physical infrastructure, and there's a variety of reasons why you would have that or want to have that in a larger organization or with multiple teams and product lines. And the same thing applies. In the most trivial of case, you simply just purchase additional USB HSMs or e-token devices for each system that you need them. The fact that they're on separate networks doesn't matter. Okay, so basically scenario A and scenario 1 and scenario 2 are effectively the same thing. And for the same benefits, nobody really has to change much of anything. Okay, so again, also very common. Now, as we get into a little bit more of complex situations, you can find yourself looking at something like this. Okay, you have network A, maybe that's your corporate network infrastructure, and you have some dev teams and some build systems on that infrastructure, and they can communicate with whatever. I can purchase HSM devices or e-token devices for each of those build systems, and because they're on-prem, no problem. Now, if network B is, say, virtual, and it's not at a physical location, now there's some question marks because there's not a physical system. And the same thing applies to Microsoft Azure. Now, in the case, and this could be something like VMware even, but if network B is hosted on a physical infrastructure and maybe it's just at a geographically different location, then that goes back to basically scenario 2. You just drop ship them a USB HSM device. Now, the challenge comes into those things are expensive. Depending on the vendor that you choose, they can be about $500 each or more. Maybe there's cheaper options, or maybe you simply, for best practice, you want to reduce the number of HSM and e-token devices that are out there. And maybe you don't want them at a geographically distributed location separate from your corporate. And so it doesn't actually matter that the network is virtual or not. It could actually be a physical network, and you simply want to reduce the number of devices, which is the same thing as basically saying we want to reduce the number of locations that a digital certificate file, TFX, the private key, pre-HSM world, it's the same thing. So these challenges introduce a lot of infrastructure concerns, and there are things you could do, like you could say, okay, you could VPN, network B to network A and have it use the build system of, let's say, build server B, build system B, and that marks as build system A. But maybe that build system is tightly controlled by that particular development team, and it requires you to do a heavy lift of changing your build processes to use their system because maybe they do code signing a certain way, or maybe everything will work fine because simply they have the USB token installed. But some people do have their own special processes. So the idea here is to break down those special processes and really make it more industry standardized across all teams, which basically means you shouldn't have a special mechanism really for actually doing code signing. It's really just the environment. So when you have unique challenges like this, you have to figure out how to solve that. And so one way to do that is basically through distributed architecture. Is yes, you might have to VPN some things together, but the introduction of a code signing server. And we've talked about this. So you build a code signing server, that is the physical infrastructure. You have one USB HSM device plugged into that code signing server. So you don't have multiple, you don't have a cost, because it is also possible that it is possible to lock yourself out of these. And so if you do that, then you basically have to purchase a new one. That maybe you just want one to reduce your footprint, and maybe you want that HSM controlled by the corporate network A. So build a code signing server and install build agents. So here you have like build system A, build system B with some build agents on there. Maybe those are the on-prem build systems and build servers that are on the corporate network. And then basically you might have your Azure networks and maybe your geographically distributed networks that are not connected, and you connect those through VPN, thus those having access to the code signing server only, and maybe they don't have access to other resources on that network. But by doing this, these teams don't have to make a heavy lift to change any of their build processes. It's a simple matter of VPN connectivity. You're reducing the number of HSM devices that the company has, which means you're reducing your risk of those being compromised, right? Because maybe you have to have devices in California, Washington, Florida, right? They're kind of all over the place. And then if you don't have offices in those locations, who's actually controlling those devices? And are they secure? Are they under lock and key? Right? Are they easily lost? And so on and so forth. And so this would really be what you would probably want to gravitate towards in a distributed scenario where you have many teams, many network infrastructures, where basically you have a single code signing environment with one USB HSM. And these environments, the build systems can be virtualized where you install the build agents, and they don't have to be full build systems. Like maybe you have a build server over here with the build system and a build server over here with the build system. And then basically you have, these really are virtual machines and not full build systems. And really their purpose would just to be have the build agent, and the build agents connect back to their respective build systems. Okay. And so that is probably the most scalable approach and the most secure approach at the end of the day. Okay. So there's different ways you could tackle this problem, but again, an approach like this allows all of your development teams to maintain autonomy. Okay. There's no dependencies between the development team. The only dependency you have is a networking dependency. That's it. It's just a networking infrastructure concern. That's all it becomes. But when you start to do things like try to tie the team's infrastructures together, commingle them, cross-contaminate, and then you start to have teams adopting other teams' build processes and build steps and build configurations, maybe build scripts. For an example, maybe a team has a PowerShell script they use that takes files from their build system, deploys it out to a remote location, requests for them to be signed, waits for them to come back. The challenge is other teams have to modify, not only do the physical infrastructure changes, which might have to tie in like network, maybe network B has to tie in specifically to network A to do that, which that's no real different than here, okay? But then they have to also change their build system, their build steps and build. Right? That's really what we're avoiding at the end of the day. We're basically saying that there's a centralized code signing server controlled by the IT group at the organization level that controls the one certificate, everything's secure, and build and engineering teams have their autonomy because that's scalable. Okay, so that would be my recommendation. There are other ways to do this, but at the end of the day, I think this is a really good and reasonable approach to this problem. The challenge is really ultimately sharing this physical USB device in distributed or virtual scenarios. Now, there are a variety of solutions out there that are plausible and theoretically could work, such as it is possible to remote desktop to an environment that has the USB device, remote desktop from an environment that has the USB device to an environment and share that USB device remotely through the USB device sharing features RDP has. That might be a possibility, but that requires a manual process to do your releases, which that's okay. There are also programs out there, Virtual Here's one, where it's possible to, again, remotely share a USB device as if you were connected to the network. And that might be a plausible solution where maybe you don't necessarily, in that case, you might actually still have to do VPN connections. So at the networking, I was explaining this to a colleague, and while I was explaining kind of what I viewed as best practice, I used the term connect. The systems have to be connected. And he asked, but what do you mean by connect?
in my brain, I was like, well, what do you mean? What do you mean by connect? Because effectively electricity has to flow from system A to system B, transfer the bits and bytes to communicate. And we do that in computer science through networking. Okay, because our Azure network doesn't magically communicate over the network to a corporate network that's locked down through VPN, right? They have to talk. And so oftentimes you might have people that think about, okay, I'm on this physical network and here's our build system and everything's good. But then when you start talking about distributed systems and scaling, then you start running into more complex scenarios. And if I was to wrap everything up, I think the ultimate point would simply be best practice would ultimately be implementing a code signing architecture that is a win-win for the organization, IT and security, and engineering, and product. And in my opinion, the best way to do that is by not introducing dependencies of one team to one team to one team, but rather implementing something like a code signing server controlled by the IT group with your build agents installed in that environment, separate from your dev and test build agents, where teams can remain autonomous and build systems and build processes can remain autonomous. That is my strong belief on this. If you're to build out a scalable architecture, I think you want to keep it as simple as possible, but you want to also keep it as secure as possible. You want to reduce your cost. You really want to reduce the physical footprint on how many USB keys you have, the locations in which they exist, who has access to them. And by doing this, you really are enabling dev teams to simply code sign as they are today. Now, there might be a heavy lift for some teams to actually have to build out a new build agent system. But I would make a good argument that if you do not have the ability to do that, that is something that you need to do and is good to do. Because every dev team should probably have, in the case, I'll use Azure as an example, virtual machine images already installed with all the build tooling and configured as they need to be with a build agent installed on there. That should be a virtual machine image that dev team could simply spin up a new VM from that image at any given point in time. And so that way you can simply scale out your build process. Okay. And whether it's Azure or VMware or Hyper-V, it doesn't really matter. Your engineering team should have build agent virtual machine images to do this. Just facilitate situations exactly like this one, where industry standards changed, physical USB HSM devices come into play, and all of a sudden you have the need to change infrastructure. But changing the physical infrastructure, I would argue in some cases, is much easier than having engineering teams change their build process for the products. Because physical infrastructure can be done a variety of ways. Typically, the build process and build steps cannot. And what I mean by that is, let's talk about a simple example of you have a build process for a component and you have, like, let's say you have Install Shield or Visual Studio installers where you need to run the sign tool command in a pre-build event as well as a post-build event. That needs to happen in one build step, okay? And where that sign tool runs at is the environment where it needs to be code signed, typically your build server. But now that piece needs to be abstracted out, okay? Well, if teams have to change their processes in such a way where it's difficult for them to abstract that out and it's a heavy lift, that's what we want to avoid, which can be solved through physical infrastructure. Okay, but if they have to write a script to go talk to Team B's system that can do code signing, right? And maybe they've designed a specific way they have to do that. And what I mean by that is, scenario I'm talking about is one that I've learned about recently, where a team had a code signing server of their own. And then they also built out their own process for accepting and whitelisting of files and authentication and some other stuff. Totally unnecessary. So that system is proprietary to that team's process. That's what we want to avoid. And it's also not necessary. Okay. So anyways, I'm very interested what other people have to say about this, but the HSM requirement is a very real one. Any certificate purchased after June 1st, 2023 now requires the physical HSM. I will say it does not have to be a USB HSM. That is just the common HSM, and some of the vendors, they call them e-tokens, e-token devices, whatever. But there is Azure HSM. There are other HSM solutions. If you have your own hardware security module, that is an option as long as it meets those standards. A certificate authority can issue a certificate and you can install it on that HSM. And so if you have your own HSM, you can build your own process. But it's really not a lot different than having whether it's a USB HSM or a different kind of HSM, actually doesn't matter. It's the same physical infrastructure challenge at the end of the day. It's all about scale, all about simplicity, it's all about autonomy. Those are the three things. And security. Cannot forget security. That really should be number one. But, okay. So we've kind of gone through everything. Pretty sure this has been a very long podcast about code signing in the enterprise type organization, pre-HSM and post-HSM worlds. Hopefully this was helpful. And by all means, I do not consider myself an expert on all this, but I do feel like I have pretty comprehensive knowledge generally on best practices around code signing and how to address some of the challenges that come along with code signing pre-HSM and post-HSM with physical infrastructure challenges. And where I think I can add a lot of value, and hopefully this did add a lot of value for everybody, is also looking at it from the perspective of the organization, the IT group within that organization, the engineering group within that organization, and also thinking about other things along that, like product. Everything has to cohesively come together at an organization and be scalable for a software organization to work operationally well. And that is the importance of implementing solutions like this, rather than complex solutions where you're commingling networks and processes and having people adapt their build steps and having particular engineering teams kind of dictate everything. You really want to centralize it in your organization and define that ownership. Make sure, do threat modeling of your process. So if you have to do handoff of physical PFX certificates that have not yet expired, do threat modeling of that process. Identify where those certificates currently exist. The whole point of this entire change in the industry is to eliminate certificate files floating around people's workstations, in email, in work item tracking systems, wherever they may be, and replacing that with physical devices that basically, by doing that, mandate a higher degree of security. And it's going to force you to think about this stuff, which is really good. But in the most simplest manner, whether it's HSM or digital file pre-HSM world, you should be adopting best practices within your software organization. So we'll wrap it there. Hopefully this was helpful. Make sure to like and subscribe and comment below, and we will see you next time.